Hi everyone. Please welcome to the second online meetup of BlrDroid. I hope everyone is safe and enjoying working from home. We have two talks today, 45 minutes each, and I hope you will like them. Whoever is joining for us for first time, like who has not joined us for last meetup, the format is basically we'll have two talks one by one. Q&A will happen after the talks, and any questions which you want to ask, you can ask on comments after the talk has finished. So, okay. All right, so we're gonna start our first talk with Subrajyoti. So let's get started. Hi, Subrajyoti.
Hi.
Hi, how are you?
I'm good.
Let me just introduce Subrajyoti is an Android developer who works at SmartCase, and he's gonna talk about Lint. I assume everyone knows Android Lint. So I'm gonna add your screen now, Subrajyoti.
Sure.
Okay. So yeah, you can start.
Okay.
Thanks.
Hi everyone. My name is Subhrajyoti, and as Jitin mentioned, I'm a mobile developer at Smallcase. Today I'll be talking about building a better code base with Lint. Uh, I'll be going through what Lint is, why you should actually care about it, a couple of examples of how we used custom Lint rules for the Ticketed Android app, how you can test your lint rules, and how you should go about adopting custom lint rules or enabling lint in your project. So let's start off by looking at what lint is. I'm sure most of us would have seen or worked with lint at some point during a development. It's a static analysis tool. So a static analysis tool runs checks on your code base without actually running it. So it won't look for things like compilation issues. Rather, it would look for common anti-patterns, performance issues, security issues, and things like that. It's completely open source and is developed as a part of AOSP, Android Open Source Project. All the rules that you get enabled by default on Android Studio, whatever you see related to edit text, text views, all of that is open source. Normally, we see lint show up for Java and XML files, but lint can work across Java, Kotlin, Gradle, ProGuard, even binary files. It can be used outside of Android as well. Initially, it was meant just for Android, but when Kotlin came in and became big, the team at JetBrains started writing some more lint checks, and they realized it could be useful for non-Android developers as well. So if you're making something like a cater server, you can make use of certain lint checks there. The tooling system is built in such a way that in addition to using the pre-built rules, you can write your own custom rules, and they use the same tooling as the one you already see. So if you need some reference, there are already about, I think, 300 plus pre-built lint rules that you can look at. And one advantage is it can be run both from Android Studio as well as from a CLI. So if you're a person who doesn't like building inside Android Studio for many reasons, you can run lint from your command line. And this also comes with the added benefit that you can add it to your CI pipeline. So you can make sure that all your builds actually pass lint. Okay, so we will take a look at how we visually see a lot of examples of lint. And keep in mind that these are not random examples. These are categorized examples. And we will be looking at the different categories going forward. So the first one is, I think, the most common lint warning that we have seen is hard-coded text. If you look at the tooltip, you will notice that it shows where your warning is in the text view. It gives us small description of your lint check and also give you an action. In this case, extracting the string resource to a different file. And the category for this would be internationalization so that you can localize your strings to different languages. The second example, though not that common, but is an important one. So if anyone has worked with WebView, you would mostly would have to enable JavaScript because almost every website makes use of it. As soon as you enable JavaScript, you get this lint warning, which tells you about vulnerabilities that can occur from JavaScript being enabled. Take a note at this lint because we would be revisiting this lint from a different perspective later on. The third category would be performance. So if you're working with custom views, it's highly recommended that you do not create objects inside your on draw, especially heavy objects. So if you look at this lint check, web view is a custom view, and inside the on draw, I'm creating the paint. Now, this is not suggested at all since your paint object would be created every time your on draw is called, and on draw is called very often. The third would be accessibility related. Even though a lot of us actually ignore accessibility when making our apps, it's still an important aspect, and that's the reason there are a couple of pre-built accessibility checks. So in this case, if you're creating a custom view and you override on-touch event, for accessibility purposes, you're also supposed to override perform click. Now coming to why you should consider enabling lint or writing custom lint rules and why you should be listening to this talk. The first is you can have an opinionated code base. So as developers, all of us tend to get opinionated about the kind of code we write. And as you work in teams, sometimes teams have opinions on how the code base should be. So if your opinions on the code base can be defined in a structured manner, you can make a lint check out of it so that whenever you write code, you can make sure that you follow that part of the opinionated code base. This also comes with an advantage that can be derived from the same opinionated code base is you can have simpler code reviews. So normally for such code bases, whenever you're reviewing the code, the first things you would look for is if they adhere to the common guidelines for this code base. And this can get tedious to do with every code review because you would by default check for those things. Now, if you had lint rules that check for this thing before it went for a code review, it would fail in the CI pipeline and the developer who pushed the commit would have to fix it. This also gives a more positive outlook to the pull request because you go to review it knowing that the common issues won't be there, and rather you should look at performance, test coverage, and other things on the code base. Of the pull request. And the third would be adherence to a style guide. A lot of big products and apps have a style guide applied across their entire app, which also reflects on the websites and other platforms. So it could be how your buttons are supposed to look, what font and what text appearance you're supposed to use for different cases. And these are things that are essential once you have the style guide enforced. Now, if someone new comes into your code base, obviously as a part of their onboarding, you would tell them about all this guidelines and in detail about the style guide. But even then, the person might miss a few things. And this necessarily isn't constrained to new developers. Even developers who have been in the team for a while, some might sometimes miss out on the guidelines. So if you're working on a certain performance aspect or you are knee deep in a very nasty bug, you might just forget or accidentally use the regular widget instead of the style guide widget, and which is quite understandable. But if you have lint rules to enforce that you do not use the common widgets, for example, instead of using a button, you use something like ticket tape button, which is a part of the style guide. Lint will throw you an error and tell you that you're not supposed to use this. This is the guideline, and this is the component you're supposed to use instead of TextView. This again makes sure that your code base is very standardized in terms of views and everything. And also, you don't have to look for these things in your code review again. We will be taking a look at two such style guide examples that we use on the Ticket Tape app to explore how to write such rules. Okay, to set up custom lint for your project, you would have to create a new module. You can name this module whatever you want. In my case, it's named as lint, but any other name works. And it's okay even if you're not following a multi-modular project, you can just create a new module for lint and things are fine. In the lint module's dependencies, you have to add two dependencies from lint, that is a lint API and lint checks. These are the same libraries that even the AOSP lint checks use, so it's very standardized. Then you have this thing called an issue registry. An issue registry is technically a register of all the issues your lint looks for. This is the standard structure of an issue registry, but take a look at the override val issues property. What this property does is return a list of references to all your issues so that lint knows what to look for. So this registry connects lint to your custom rules. Since you don't have any custom rules written yet, this is an empty list. After you have created this registry, you have to link this registry to your module. So you have to add this jar block to your lint modules BlrDroid. The reason there's a jar block here is whenever your app is compiled, this creates a jar out of your lint checks, and Android uses that jar to check all of the lint rules. So if you're writing a library that has such rules and you ship that library, anyone including the library will also get a jar with all the custom checks for the library. Similar example for this is Timber. So if you have used Timber by jQuadrant, you will notice that if you're including Timber in your project and then using Android's login class, for example, log.d or log.e, you will get a lint warning telling you that you already have included Timber, so it might just be better to use Timber instead of log. Once you have added this jar dependency, you have to go to your apps BlrDroid and link your lint module to your app module. And the way you do it is using this lint checks. You can see that the tooling is properly built out because there are separate tags and methods to integrate lint into your code base. Okay. Before you start writing custom lint rules, there are three common things that you should know about. First is the scope, then it's a category, and then comes the severity. So first we'll take a look at scope. The way you tell lint to check for issues on certain files is by using this scope. It would be very expensive if lint ran your checks on every type of file that is in your code base. And that would be a performance issue as well because you can have a lot of such files. So by using scope, you narrow down the number of files on which the lint checks need to be applied on. So you have a Java file scope, Gradle scope, manifest, ProGuard, resource file. These are just some of the scopes. There are other scopes as well, which can be used to combine two scopes. So if you want something that runs on two particular scopes, there might be a third scope defined by lint, which is a combination of those two. And since the lint API was made when Kotlin really wasn't part of the Android ecosystem, there is still only a Java file scope, but this also applies on Kotlin files as well. The way this works is lint directly doesn't apply on Java files. It rather works on a super type of both lint and Java, which is UAST, Universal Abstract Syntax Tree. So the abstract syntax remains similar for Java and Kotlin, and that's the reason the checks that you write for Java files also apply on Kotlin files. The second would be the severity. What is the severity of the one second, I think I repeated it. Okay. What is the severity of the error or warning that the issue link finds? It could be informational, warning, error, and fatal. Informational is when you want to give a certain information to the developer and not really cause an error or warning. This could be in case of your opinionated code base example. A warning could be something that's highly recommended for the user, but it shouldn't cause a link to fail. Error is when link is supposed to fail for that issue. And the last type is fatal. Fatal has to be used very carefully because if you have an issue that is fatal and you're trying to build an APK, even that will fail. Fatal is like the most severe, which can be destructive to your code base. I mean, it should be used for issues which could be destructive to your code base. The third one is category. Now, again, here I'm showing 4 categories, but there are many more such categories. The 4 categories, again, from the examples we've seen before, were security, performance, internationalization, and accessibility. There are many more, but I took these 4 because I could show examples of them from the pre-built. And you might see that I've written I18N. So I recently realized that I18N stands for internationalization because there are 18 characters between I and N. Similarly, for accessibility, there are 11 characters between A and Y. So it's A11Y. Similarly, localization would be L10N. Okay. I had mentioned that we would be looking at 2 examples from our app and see how we wrote custom link rules for those. So both the examples are related to style guides. The first style guides we'll be looking to is TextView. So if you take a look at the image, you will see that there are 2 different types mentioned. One is H1 display mobile, H2 display mobile, and there are many more like H3. There could be caption. There are many such modes, many such types. And each type has a set of properties that will be applied for that type. Initially, we were using custom views for these text views and different attributes, but later on, we decided to move to styles as they were much more flexible. So what our lint checks need to do in this case is if someone is creating a text view, they have to add a style to it. And this would be an error because if they don't apply a style to the text view, we can have design inconsistencies in the app. And since it's a highly enforced design system, we need the style to be there. So let's take a look at the custom rule structure. At the core of your structure, you have something called an issue. This issue is the one that is connected to your issue registry. So this becomes a core part. This is the way you create an issue. I'll be going step by step to each of the parameters. The first parameter is your issue ID. This is the unique identifier for your issue. And if ever you need to do anything with this issue, you'll be using this ID. For example, if you want to disable this particular lint rule, you'll be referring to this ID in your lint options. The second is a short description of your link. It's the first thing that shows up in your IDE. The third would be a longer description in which you can add more details as to why this is an error. You could add links to your style guide and such things. If you come to the fourth parameter, here comes the categories we have mentioned. Since this doesn't fall into any of those previous mentioned four categories, we are using the correctness category to define that it is incorrect to use text views without style. The next parameter is a priority parameter. This you can skip. I personally couldn't find any difference while changing the values, but if anyone knows anything about it, I would love to know. Next comes the severity. As we had mentioned, the severity could be informational, warning, error, or fatal. In our case, we want it to be an error because we strictly want styles to be applied to text views. And then comes the implementation part. You have the issue, but the issue also needs to link to your implementation of the rule. There you mention the class. So it's just not the class name, it's class.java because it needs a class. This is a reference to where your implementation lives, and also the scope. So in this case, the scope is resource file scope. Now, you might have one concern at this point, is that we would be defining text views in XML only in layouts, but resources have a lot of different kinds of XML files. So this might needlessly run on a lot of other files as well. So we will be fixing this shortly in the next step. In terms of scoping, there is sometimes you might not get very fine scope, or rather, you would get gentle scopes. So in the implementation, you have to fine tune it. Okay. Since this is a lint rule for an XML file, our class needs to extend resource XML detector, since this is looking at resource XMLs. Similarly, if you're looking at Java code, you could have a Java scanner. You have different UAST scanner. If you want to do more about the structural issues of Kotlin and Java files, a source code scanner to go through the entire source code. It depends upon your usage. I mean, your context of where you're using this lint rule. In this case, resource XML detector works fine. The first thing that you override is get applicable elements. This specifies which particular elements will your lint rule run on, and you might have one lint issue that can run on multiple types of elements. That's why it takes a collection as a return type. But in our case, we wanted to apply only to text views. So we pass in a list of text views. Now, as a coding practice, it's a bad practice to use hard-coded strings. So what you should be doing is using a constant. Fortunately, the lint library has a huge collection of constants which you can use from. If you're using if you're writing a rule for any of the Android's widgets which are pre-built, it's almost certain that you will have a constant corresponding to that in SDK constants file. The reason it's really good to use a constant, because I personally misspelled a certain element once and I spent a lot of time figuring out what went wrong. The next method that you need to override is applies to, and this gives you a folder type. Now remember that I mentioned our issue was not very fine-grained. We were looking at resource files. This override method is where we specify that inside resources, we want to look at only layouts. And what happens when Android or lint finds a certain element, which is a text view in this case, in a resource layout file? What does it have to do? Here comes the logic of checking things. So in this example, we get access to a context and an element. The element here is our text view. So we check if the element has an attribute called style. Again, we are using a constant here instead of hard coding style. If element doesn't have the attribute style, then we report that lint issue. And while reporting, the first parameter is issue, and this is the same issue you had created in the beginning. The element is the widget or any file type or anything that your rule should show for. That's your element, and also the location where it needs to show. That you get from context.getLocation. And the next one is a string message. You can keep this anything you want. So you have completed the custom rule. Now you need to add your issue to the registry so that Lint can pick it up. In this case, since you have only one issue, you get access to the issue and add it to the list. Now, remember that I mentioned get applicable elements was an important override method. We will take a look at an example of where get applicable elements or something corresponding to it was not mentioned and it caused a bug. This is a small bug and not many people are likely to come across it. But remember that I showed a security lint check where setting JavaScript enable would show a vulnerability lint error. In this case, I am not using web views at all. I'm using a random class, and inside that random class, I have a function called setJavaScriptEnabled. If I call this particular implementation of setJavaScriptEnabled, I will still get the vulnerability lint checked, which technically isn't correct, because in this case, my JavaScript enable could be doing anything else. This happened, it's an AOSP rule. This happened because a corresponding statement like get applicable elements or a filter wasn't applied, which should check that if the calling object is an instance of WebView settings. If such a constraint is added to that lint rule, this lint warning will disappear. So that's the reason always remember to add proper constraints for all the lint checks you write. Otherwise, you'll just keep getting random lint checks, which won't really make sense. Coming to the second example. In our app, we have a custom implementation of a Snackbar. We don't use, for example, the material libraries Snackbar. So we needed a lint check, this time in Java code or Kotlin code. If someone uses Snackbar, material library Snackbar, we tell them that do not use that, use a custom component to align with the style guide. So let's take a look at how we would implement that. The issue structure is again similar. The only difference you will see is towards the end in the implementation, my scope is Java file scope. It's earlier we were using a resource scope. This time we're using a Java file scope. Also remember that Java file scope applies on Kotlin files as well. Now looking at the structure of the lint rule, this will have a lot of similarities compared to the previous rule. In this case, we are not extending from XML scanner, resource XML scanner, but rather we are using the detector interface and the source code scanner. These give us the necessary callbacks we need to implement our rules. Now, in this case, since we're working with Java files, we would look at classes, the kind of methods that they're calling, and the parameters of those methods. And this lint rule is kind of inspired by what Timber writes, but the Timber's lint rule are much more complicated because they provide fixes whenever there's a lint error. In our case, we don't provide fixes. So get applicable method names, we look for the make function invocation. So normally if you're creating a snack bar, it would be snackbar.make. So we're looking for this make method name. But like I mentioned in the previous example, we also have to add a constraint of the file on whose instance this make is being called. So the other override method that we use is visit method called. So whenever the method function is invoked, we would get this callback. Now inside this, we get access to the context and other parameters which we won't be using. So, I mean, we would be using the method parameter to get to know the method name. So we have to check if that method is actually a member of the material snackbar class. So that's when we use the context to get the evaluator, and the evaluator checks if this method is actually a member of the material snackbar class. Now, given this constraint, if there are make methods in different classes, it won't apply on them. So we won't come across such a bug. And if this condition is met, then we just report the usage similar to how we did for TextView. Now that we have seen two examples of custom lint rules, the next concern comes is testing. So ideally, when we write such new things in a code base, we want tests to make sure that they are done properly and we don't break them at certain point while making changes. So testing with lint is actually pretty convenient. You write normal JUnit tests, so they're extremely fast. Android gives you a lint-test library which provides certain DSLs to make your testing comparatively easy and saves you a lot of boilerplate. And the third would be Android Studio and IntelliJ have syntax highlighting as well as syntax checking for the code you write in your lint rules. Let's take a look at one such example. This is a test for a lint check. Don't look at the implementation completely. Focus on the text view part. You can see that my ID is informing me of a certain error. And this looks like a syntax error. If you look at the second line of text view, you will notice that I haven't closed the quotes. After match pattern, there is no code. And as expected, the ID is giving us a syntax warning as well as highlighting the text view widget as well as the namespaces. So this makes it very easy to have a glance of what are the things being included in the test. So before you start writing the test, you have to add the dependency for your lint-test library. This will be included in your lint module. Okay, we will be looking at two cases. One case where after running lint, you're not supposed to get an error, and a second case where running lint will give us an error and we will test that error. So the first one is to check for like lint errors. I mean, for no lint error. So you start by adding the lint method call. This starts the DSL. Next, you start calling a files block. This files block lets you define the kind of files you want to run tests on. It could be Java files, Kotlin Gradle scripts, XML files, a lot of such things. It's similar in terms of scope, but it's broader than that. I mean, you have more choices. Since we want to test an XML snippet, which has to be in the layout resources. So we create this kind of a mock XML file where we mention that the path is in resource layout and it is in a file called layout XML. And then we mention the code snippet on which we want to run a lint. If you see, there is a style attribute on this text view, and there should not be any lint errors for this snippet. Also note that my text view is indented to a certain extent. You have to be very careful while adding indentation while writing your tests, because the result of the test will vary depending on your indentation. Lint will ideally want to pinpoint the location where the error occurred, which would include the column number and the row number. So if your indentation changes, technically the test also changes. But in this case, since we're not expecting any lint errors, any kind of indentation works for this particular case. Once you have defined your XML file, you click the run block. This runs lint on the particular file, set of files that you're providing. Now, after running it, what do we expect? We expect that there should not be any lint error. We call the method expect clean. This is a test that will pass since there are no, like, we are sure that there won't be any lint issues because we can see that the style has been added here. The next example would be an error case where lint would throw an error. This test remains very similar to the previous one. The only difference is I have removed the indentation to make the test simpler. And this test does not have a style attribute. So you proceed to running that running lint on that particular XML file. Here we expect only one error count because we just have missed out on the style attribute. So our expected error count will be 1. Now, in case you are expecting a warning, you could keep expected warning count as 1. You can even mix them both. In case you expect to get 1 warning and 1 error, you will get the same. So you can expect, so you can write expect error count 1, expect warning count 1. Now we have just checked for the count of errors, but we also need to check if the output of the error is what we expect. In this case, in the expect block, we run the output that we expect from lint. At first, we mention the file name, the line number, the description of the lint, a pointer to the location where the lint error occurred, and the number of errors and number of warnings. Now, this might be very complicated to write. So if you're sure that your lint check works properly, you can run it on a few test file, mock files that you write that you can create. And then what you can do is call an empty test block with just an empty string, run the lint, you will get an error. Your test will fail and it will tell you that there is a mismatch. You can look at the actual output, compare it with your lint. If you see that it's a proper output, you can place that in your expect block. This will make sure that future changes to this lint rule won't break it. And since you can see that there's a pointer to the exact location of the error, that's the reason indentation was very important. If you're planning on integrating lint with your code base, first thing is do incremental fixes. Do not try to tackle all the issues at one go. You will end up with a lot of such problems. Instead, use something like a baseline. So a baseline is a way of adding all your existing lint issues to a file so that it filters out the same issues from future builds. So in a way, you tell lint that in a way you tell lint to ignore whatever your existing issues are, and going forward, it should throw errors for whatever issues come. The way you do it is add the lint options block in your apps build.gradle and add a baseline file. You don't have to create the file. Lint will create it the first time you run it. So if I run lint debug, if I run lint on my debug variant, I got one error for my project. You can see that lint wrote an XML and HTML report first, and then it also wrote those to my baseline file. And the file name is the same as what I had mentioned. If I run the same checks again, this time my build will be successful, but it will mention that it did find one error, which was filtered by the baseline XML. If you open up the baseline file, you can see that my issue was registered in an activity underscore main file, which I had created earlier. It tells the issue and also the line and column number on which it occurred. The last consideration which many people have while integrating lint is performance, and it's a pretty valid concern. Looking at lint, there are two main categories of lint checks you can think of. One is a single pass and one is a multi-pass. So a single pass example would be missing attribute, like in our case, the TextView example, which can happen in one pass. And since it's only one pass, it's fast, and these are usually enabled in the IDEs. So the hard-coded string or the accessibility issues, these can be found in one pass, and so they're enabled by default in your IDE by Google. The second would be multi-pass. An example would be unused resources. You might have noticed that the IDE doesn't warn you about unused resources by default. It's only when you run a custom task or run it while adding a git commit that you get to know about unused resources. Because this is multipass and it's slower. And they are disabled by default in your IDE. Normally, you would want to add these to your CI because a few seconds more on your CI might be fine, but lag if a developer faces lag while writing code in his IDE, that really isn't productive. And that's mostly it about lint. If you have any questions, we have a Q&A session now as well, or you could ask me on Twitter that's my Twitter handle.
Thanks, Subrajyoti. So yeah, if you have any questions, please add them in the comments. We'll take 5 questions at max at this time. So, okay, we have a question. Let me just highlight it. Subrajyoti.
I haven't tried using lint as a plugin, considering the IDE support as well as command line option has worked great for me. So I haven't really tried using it as a plugin.
Okay. Actually, people have been asking for a sample project where if you could showcase. So I think this is the question regarding that only.
Yeah, I'll be sharing the link to the slides as well as a sample project.
Okay. Okay, then we'll conclude this session. Thanks, Surbhajyoti, for joining and giving this session on Lint. Yeah. Okay, so we are now gonna move to our next session. Let me just add Akshay to the stream. Hi, Akshay. You are muted. Yeah. So yeah, now we have our second section with Akshay, which is regarding Kotlin Flow. Akshay has joined us all the way from Berlin in a different time zone, and he works as an Android engineer at Clue, and he is also a Google developer expert for Android. Akshay, over to you.
Yes, thank you for such a warm introduction. Let me share my screen. And, uh, are you able to see the screen?
Yeah, I've added to the stream. Yeah, go ahead, Akshay.
Okay, perfect. Hey everyone, it's super exciting to see people from India and so many familiar faces, um, and even some people joining from other parts of the world. I hope everyone is coming up with creative ideas while at home and staying safe. So yeah, welcome and thank you for joining. I'm Akshay Chodia. I'm based in Berlin, Germany. Originally, I'm from Pune, India. So I over here I work as an Android engineer at Clio, which is a female health company. I'm also an Google developer expert for Android. And today we are going to talk about something which many people are excited about, that is Kotlin Flow. So the goal of this talk is to tell you why Kotlin Flow was designed, some basics, show what makes Flow special, how you can migrate to Kotlin Flow, how to architect Flow on Android, and most important, testing. So before we go into what Kotlin Flow is, let's rewind a little bit and look at what Kotlin gave us, that is coroutines. So they simplify. So what are coroutines? They basically simplified asynchronous programming in general and especially on Android. So let's take an example of an synchronous function called as show user, which internally loads the user from the database. So when this function calls load user, it blocks the current thread and waits till the user is loaded from the database. This blocking is bad because at this moment the whole UI is frozen, making the user unhappy, which you would definitely not want. And once the data is loaded from the database, the render function is called, which like renders the user data on the UI. So there are like multiple ways to, yeah, okay, yeah. So there are like multiple ways to tackle this. So let's look at how we can like tackle this problem using coroutines. So let's start by taking the original synchronous function again, show user. And so first what we'll do is just mark the show user function with the suspend keyword. Of course, we will need to mark the load user function suspend too, because since we also want that function to run on the background thread. But there is a problem. The render function needs to be called from UI thread since it's touching the view hierarchy. So we can, in that case, we can just use the with context function, which allows us to switch the thread inside the suspending function. So it will switch from background thread to UI thread, and the render function will be called in the UI thread. And that's pretty much it. That's pretty much it, how you can convert a synchronous function into asynchronous using coroutines. So let's look at how it will work internally. So we start by calling the show user function. Since it's marked as suspend, it will automatically switch to the background thread or the thread which you specified while launching the coroutine. And then the user will be loaded from the database on this different thread, while the main thread continues to go ahead without waiting for anything. That is, it is not freezing or blocking the user experience. And when it will it will switch back to main thread because of the with context function when the data is loaded, and then it will call the render function on the main thread and basically display the data. Okay, so one key thing to remember is the suspend function can only be called from another suspend function or from a coroutine scope. So let's look at what coroutine scope is. Coroutine scope represents the scope of the coroutines. So each coroutine needs a scope to run in, and so scope is basically more or less associated with the life cycle. So when the scope is destroyed, all the running jobs inside the scope will be stopped or cancelled. So this scope is generally associated to lifecycle, like I said before. For simplicity, for instance, on Android, each activity has a lifecycle. So a coroutine scope. So the one of the KTX library provides the lifecycle scope, so where you can like just launch coroutines, and they will be destroyed when the activity is destroyed. So let's look at an example to understand this better. For example, in order to call our show user suspend function from a normal function, we would need a coroutine scope, as we saw before. So, and like I already said, like on Android, these scopes are already implemented for us for convenience, like the lifecycle scope, which is part of the lifecycle KTX library from Jetpack component. It is provided to use coroutine function in activity or fragment. So it's a coroutine scope which is tied to the life cycle of activity or fragment. Yeah. So this provides the magic of automatically clearing or canceling all the jobs running in the specified scope. So when the activity or fragment is destroyed, it's pretty much similar to how you would do it in RX, where you manage a subscription and then unsubscribe, like clear all the subscription in destroy or something. So this is done automatically using scopes in coroutine world. So the launch scope, the launch function is used to start the coroutine, and it will immediately start the coroutine. That means the coroutines are hot in nature. This is also one of the reasons why coroutines are not like one-on-one replacement for reactive streams. So basically, a coroutine scope is kind of a subscription management system associated to lifecycle. So this concept is called as structured concurrency, and this is what makes Kotlin coroutines so powerful and also helps developers prevent leaking the job or the subscription which they were supposed to cancel. So let's come to the important question: why Kotlin Flow? So like I said, like with coroutines and like with the growing usage of Kotlin and love for coroutines, people expressed a lot of interest in having a pure Kotlin implementation of RX Java to leverage all the amazing features which Kotlin provides. But the Kotlin team came up with the confusion. So the confusion was should they create some sort of a magic or wrapper on top of RX Java to leverage Kotlin, like RX Kotlin in a way, or to build a whole new library from scratch, like the whole new reactive library. So in case if you don't know, RX Kotlin does exist, but it doesn't like it leverages some of the Kotlin features, but it cannot like leverage all the amazing features, especially like coroutines or something like that. From my perspective, it's important that any library, any new library raises the bar compared to any existing library out there, and is not just a simple replica with slight improvement. And Kotlin Flow does raise the bar. We will see how it raises the bar. So like I said, let's look at what's special in Kotlin Flow, which makes it raise the bar. So first is Kotlin provides null safety in the stream. That means you cannot send null values in the stream. So this is not something new. RX Java has it too. Second is like the interoperability. So this is the key thing. Flow provides an easy APIs to convert Flow to any reactive stream like RX Java Flowable and the reverse. Also, you can combine Flow and coroutines. We will see this later today. Also one more nice thing is like it supports Kotlin multi-platform, so you can actually use Kotlin coroutines and Flow on any of the supported Kotlin platforms like JVM, JavaScript, and native, or you can like put it in the shared code or common code like the Kotlin multi-platform projects, like basically, and use it over there. One more thing is like there is no special handling for back pressure. There are like literally like no operators for handling back pressure because this is handled magically by the suspending nature of coroutines. Though like that said, like there are some things which you can configure, but like more or less you don't need to do any special handling. Also, there are like very few operators, not because it's not the library is not ready, but it's just because of Kotlin and coroutine. So which directly correlates to ease of understanding. This is because of two reasons. So Kotlin's extension function magic, so it does that. plus like because of using coroutines, you can basically have the same operator to do synchronous and asynchronous code, which cuts down the number of operators with Kotlin Flow. Yeah, and also like the perks of structured concurrency, which I talked about, like the scope and clearing the subscription. Okay, so let's look at what is Flow. So Flow is based upon reactive stream specification. So basically, like all of the reactive stream libraries out there follow this similar specification, like RxJava, RxJava 2 and 3, and also Reactor, and also Flow also follows the same specification. Also, for like you can actually think of Flow of something like a list or a collection, except it's like just cold in nature compared to a list. It also has like all sort of operators like a map, switch map, etc., similar to any list or collection. The key thing is like it's built on top of coroutines. We will see why making it built on top of coroutine is like so amazing. And the key thing is like it's cold in nature. Okay, so let's look at some of the basics of Flow. So essentially, like there are two components, emitter and collector, where emitter emits new value and collector receives the value. Here is an example of an emitter. So here here's an example of an emitter which returns flow of string, very similar to how you would return a list of string. So there are various ways of creating a flow using something called as flow builders. So these are like functions provided by Kotlin Coroutines library to create flows. So it internally creates the flow for us. We'll come to this also later. So since flow is cold, nothing inside the flow builder block will be called until there is a subscriber or a collector observing the flow. So no. Okay, let's look at collector. Here we have a main function which gets the flow inside the run blocking function. For people who haven't used coroutines, run blocking function is a blocking coroutine scope. That is, it blocks the current thread until everything inside the block is completed. Generally, this is useful for testing. So let's understand how things work internally. So initially, the main function calls the stream function, and which immediately returns the flow back to the main function. And, okay. Then we call the collect function on the flow, which essentially means we are subscribed to the emitter. So as soon as we are subscribed to the emitter starts emitting the values sequentially. So it emits the value upstream. And as the emitter emits the value, the collector receives them, and in this case, prints them. And then the same loop happens, emitting the next value. You get the football, and this goes on until the emitter says that hey there, I have no values, and that's when the execution moves out of the collect block and is complete. So let's dive a little bit deeper and see how this is working internally. So as I mentioned before, flow is based upon two components, a collector and an emitter. So essentially, they are just interfaces. So following interface over here represents the interface for collector, which exposes the collect function. And the other one is the emitter interface, which allows emitting values. The key thing to note over here is both the functions are suspend, which allows, this is what allows the magic of interoperability with coroutines. This is how, like as we saw before, like only a suspending function call a suspending function, and because the collector and emitter are suspending in nature, you can allow internally you could call any coroutine, any other suspending function. And this also brings the same advantages which coroutines have, like that is the structured concurrency. The funny thing is the whole mechanism of flow is essentially emit and collect function calling each other. So these two functions are internally called so that's the whole mechanism of flow. So flow loves coroutine also because it's built on top of it. So let's say you have a function which loads some data from database. Since this operation takes time to perform, you would ideally want to perform it in the background thread by marking it as suspend. And the funny thing is, oh, did I miss something? Yeah. So funny thing is, you can directly call any coroutine function inside the flow block, like we saw before, because the interfaces are suspending in nature. So you could just directly call load from database inside the flow builder, which is amazing. Um, so this is because like the flow builder accepts a suspending lambda, and also because like the collector and emitter are suspend functions. Yay. Okay, let's look at like the core principles or the ideology of flow and how they make our lives easier. So with flow, you can define or switch the thread by using the operator called as flow on, which takes in a dispatcher, which in this case is IO. Uh, so this operator, like the flow on operator, sets the specified thread only upstream. So anything above the flow on operator will run on IO thread basically. So the map operator below the flow on will run on some different thread and it will not be IO thread. So this context of preventing context from leaking is called as context preservation, where the context is like encapsulated and it's never allowed to go downstream. So that basically there is only one way to change the context of a flow, which is like upstream. So if you compare this to Rx Java, where it's like super confusing, especially for beginners to understand which thread their code is going to run on. So in the example above, you can see that only the first subscribe on is applied and the other one is ignored. So this is like super confusing, and unless like you really know Rx Java, it's really hard to know like how like to predict what's going to happen. So combined with another operator to change thread in Rx Java, that is the observe on operator, it just gives you like a face palm moment. Okay, so exception transparency. So this is like the second principle or the ideology of flow. So flow implementations never catch or handle exceptions that occur in the downstream flows. So this is they catch the exceptions only for upstream. This is again due to context preservation, which we saw before. And there is only one operator to catch error, which is the catch operator. Let's look at an example. So let's take the previous example of flow, which tries to get the value from the database and emit. As you can imagine, anything can happen here while loading from database, and the database operation might throw any sort of exception. So very similar to try catch block, flow has a catch operator, which will help you catch any exceptions thrown upstream. You can even use like if you don't like the operators, you can even use a classic try catch block. It will behave exactly similar to the catch operator. So, but I would recommend to always use the catch operator. But there are use cases where you want to have the classic try catch block. But just make sure during those times just to ignore the cancellation exception, because you don't want to emit an error when your flow or coroutine was cancelled because the activity was closed or something. This is pretty much and this is pretty much how the catch operator works internally. Or like if you really want to like stick with the classic try catch block, um, you can then specifically handle the exception which you expect to see. So you don't need to handle the cancellation in that case. So for example, in case of database operation, you would you would know that like there might be some IO exception, and you can just like go with the specific one, so you don't need to handle the cancellation. So the value emitted from the catch. So basically, in the catch, you can emit a fallback value or something. So the value emitted from this block is again received in the collect. That means there is only a single place to handle all types of cases. Like either they can be success or failure, but all of them just directly come to collect, which makes it super transparent to handle all the cases. I would recommend to toss in sealed classes so you always cover all the cases of your code. Okay, so at this point, it might be confusing to understand when to use suspend and when to use flow. So here is like a rule of thumb. So the rule of thumb is like use suspend for one-shot operations, like inserting into database or into a file or something like that, or a network operation. Um, and use flow when there is stream of data involved. For example, getting the data from the database where you want to continuously listen for updates in the database and update the UI or something based upon that. Okay, right. Like everyone has legacy code, and at some point you would want to like migrate that legacy code to Flow. And so this is one of the coolest thing, and I love it a lot. Like Flow provides an amazing API to convert any legacy callback based API to Flow. So let's say you have a function which has a listener, and this listener is triggered each time the document is updated. So, and again, like you need to make sure to remove this listener when the component is destroyed. For example, when the activity is destroyed. So Flow provides an API called as callback flow, where you can write the legacy listener, aka your callback, um, and offer the like an offer which basically means emit this value each time the document is changed. But now at this point you would be like, but we also need to remove the listener at some point, right? So Flow provides a function called as await close, which is called when the flow or coroutine is cancelled, where you can like safely remove your listeners. Finally, with the code comments, it looks something like this, which a lot of people forget to write. Okay, that was like callbacks, but let's say you have some like if you decide to switch from Rx to Flow and you have some kind of Rx Java code already here, my goal over here is to not tell you to go next moment and migrate your code base to Flow. I mean, that would be great for your own project, obviously. But yeah, just give you an idea if you decide to migrate and how that looks like. So as we saw before, like Flow and Rx Java follows the same reactive stream specification. So in theory, it's very easy to convert data streams from Rx to Flow and the reverse. And there are like two ways to convert. Like one is like you first like refactor your Rx implementation to use Flow, but that's like time consuming. And sometimes you just want to switch the type, like from observable to Flow. So you can like have some sort of layers where you have legacy code with observable, and you can just switch it to Flow for the newer parts of your app. So this function, like as Flow, it converts your observable into a Flow, and the same can be done to convert Flow to observable or flowable when you need it. So this is for Rx Java 2. So I created this small chart which I stole from Clue's documentation. In my defense, I created this table at Clue, so I think it's fine. And so it's a quick comparison of terminologies between RxJava and Coroutine. So use this chart as a reference when you're new to Coroutines world or working on migrating from Rx to Coroutines or reverse. Yeah. Yeah, and now that you can also see that like we pretty much covered all the things mentioned in the table except like channels. So let's look at something really fun. So the as flow function which I showed you before, which converts like the observable into a flow, actually uses the callback flow API internally to convert the observable to flow, which is like so cool. Also, fun fact, like if your code base is stuck with RxJava 1 and you want to move away, I would recommend to migrate to Kotlin Flow rather than like RxJava 2 or 3. And since this RxJava 1 bindings are not officially supported by Kotlin team, I have created a library for those who need it. You can go to the link below to use the library if you want to migrate from RxJava 1 to Flow. It basically offers the same API for RxJava 1 types to convert from coroutines to flow or reverse. It is exactly similar as RxJava 2. Now to everyone's favorite topic, testing. Testing flow or coroutines is actually pretty easy. So let's take an example of a simple flow of string, and let's write a test function and use the run blocking coroutine scope because we want our test to wait till the coroutine is completed. Like I said, like flow is similar to a list or a collection, where you could just like so you can just use the take operator. Yeah, so you can just use the take operator to pick the first value from the stream, and then convert the flow to a list. So you can easily assert it. Or you can just copy use this extension function which I again stole from our Clio code base. Sorry, but yeah, in my defense I created it, so I think it's fine. So with the extension function it would look something like this, much more cleaner, I guess. Okay, to conclude, so here's a quick summary of what you learned today. So we revisited coroutines. We saw why Kotlin Flow came into picture and what makes it special. We saw basics of flow, that is like the emitter and collector and how they work internally. We saw principles of flow. Principles of flow, that is context preservation and exception transparency and how they make our life easy. Then we saw how to convert Rx or legacy code to flow. And we saw the cool callback flow API. And then we saw like how you can test your flows or coroutines and some pro tips along the way. So to conclude, like Kotlin Flow raises the bar and makes like reactive programming in general like easy, and gives us great Kotlin features. That said, it's like still work in progress, and there are like a lot of exciting things which are coming soon, like the state flow and some of the really amazing stuff. And yeah, that's it. Thank you. If you have any questions, just feel free to put it in the chat.
Thanks, Akshay. Thanks for that enlightening section on flow. Yeah, so if anyone has questions, please put them as comments.
Yeah, so I think there is
Yeah,
one.
there is a question. It's not coming in our stream. So let me just say it here. What is the difference between channel flow and callback flow? Okay, they are here. I have highlighted it.
Actually, I haven't worked with channel flow, but I think in general, like you would want to use like I think I'm not exactly sure because I haven't used channel flow as such. But in general, like this brings me to a interesting topic like about channels, because like generally like the Kotlin team recommends that you use channels like inside the functions or something, and then you would always want to expose the not the channel but the flow. So you can just convert your channel into a flow and return it.
Okay, let's move on to next question.
Okay, so why use offer, right? So inside the callback flow, like if you dive into the code inside the callback flow, it's internally using some the channels, and the channels don't have this emit function since uh, they don't use the same interface, and they have the offer, but essentially is the same thing, just like different names.
Okay.
Right. I think that's a really interesting question. So I think you would want to use lifecycle scope when you, for example, you want to use something like flow bindings. So if you have used RX bindings before, like where you want to, where you have a text view or something, or like you want to listen to text view changes, like no, sorry, not the text view, the edit text. You want to listen to edit text changes, so you would use the RX bindings and convert it into an observable. So that's, I think that's one of the case where if you want to use flow, you would use flow bindings and then convert that text change listener um, into a flow, and then I think that's when you would come up with a scenario of using lifecycle scope. But I think I think you would not usually use that physical scope if you write like a really good code, like architecture code, I mean. But yeah, it's there if you need something.
Okay, next question.
Okay. Um, yeah, so like so upstream and downstream basically means like so this is like actually super simple in a way. Upstream means basically anything about the function or the operator, and downstream is like when you call the collect. So all the values, so let's say you have a flow function, you have the map operator, and then you have the collect. So the values so what, it's just like words which we use. So whenever like in the flow builder you emit the values, so they are coming from upstream to the downstream in the collect. So it's basically something like that. I guess
Okay.
it's
Yeah. Okay. Then last question. Yeah.
what do you mean? I don't get the question here. Like, what about the support for operators like
So
that?
I'm assuming he is asking about the operators which we have in RX Java, right? Like
Mhm.
map, filter, and all. So are they available in Flow also?
Right. I think so. Most of them are available, and I think a lot of them are available. And but the special thing about Flow is like they don't need one-on-one mapping. So let's say RxJava right now has 30,000 operators. Yeah, Flow can do that in 10,000 operators. The same thing which RxJava does. So yeah, but I think some of the operators are still missing, like the share, replay, or uh, I think ref count, something like that. So the connect table observable, basically, those operators are still missing in Flow, and they're like coming soon.
Okay. Thank you, Akshay.
Thank you.
Uh, and if anyone has any other questions, he can always contact Akshay on Twitter. So we have shared Twitter details on the meetup as well as in this live stream. Thanks, Akshay, for the
Thank you.
presentation, and thank you for joining us.
Thank you.
So, okay. So with this, we would like to conclude this meetup. Thanks everyone for joining. This is our second online meetup, and I hope everyone would be joining the Android 11 beta launch, which is happening on 3rd June. So let's see what exciting news comes around at that point. So, Brijesh.
Yeah, thanks everyone for joining. And if you want to give a next talk in the next meetup, please use our CFP form. We'll retweet it on our Twitter handle. So yeah, stay safe.
Yeah. Okay, thank you. We are always available on Twitter and Slack and Meetup. So if you have any questions around anything, please go ahead and fill up the CFP form for if you want to speak on our next meetups. Thank you, everyone. Okay, have a nice weekend.
Yeah.
Bye.
Bye.